Okay, so today's lesson 3.4 is about solving quadratic equations by factoring. To be honest, we've already been doing a lot of this. If you think about the concepts we've already covered, really, we've always been finding our x-intercepts, and those x-intercepts, those points where it intercepts the x-axis, the x-intercepts, those are your solutions. That is you solving a quadratic equation. All right. And at those points right there, at these points, the y value is 0. So what this paragraph is telling you right here is saying that you set the y to 0, you set the y to 0, and you solve for the x values that would make y 0. How do you solve? You solve by factoring. So today's lesson isn't super long. I think we have, just 2 examples. All right. So we're solving each of these examples in one by factoring. So let's look at example 1a. When you look at this problem, you see that we are given a quadratic equation in standard form, and our a value is not 1. In this case, it is 6. Can we make this 1 though? Like, can we factor all of these by 6? No, you can't. All right, so then we're stuck using decomposition. So remember, you take the 6, you take the negative 10, multiply them, so you get minus 60. You need two numbers that multiply to give you minus 60, and you need those same two numbers to add up to give you negative 11. So go through your multiples of 60. So 60's multiples, 1, 60, 2, 30, and you just keep going until you can get some combination of 11. And there we go. If I make this negative 15 and this positive 4, and how do I know that one is positive and one is negative? Well, once again, in order to get a negative here in the multiple, one has to be positive, one of them has to be negative. So in the case, I know it's minus 15 and 4. So minus 15. So decompose that middle term. So you get equals 6x squared, and then we have plus 4x, and then we have minus 15x minus 10. So again, this 11 became now those. Do your grouping. So group the first two and the last two. And in the first two bracket, take out your GCF. So in this case right here, I won't always write this, okay? But just for the first one, let's look and see our GCF is 2x. So we can pull a 2x out of the bracket, and that would leave us with 3x plus 2. And then if we look at the other bracket, we can pull out a minus 5. So minus 5 would be our GCF. And you'd be left with 3x plus 2. And again, you know you've done it correctly because this bracket and this bracket are the same. All right, so then you get your two factors to be 2x minus 5, which are the things on the outside here. And then you get 3x plus 2, that common bracket. And remember, this was all set to 0, okay? So actually, my communication's poor. I should have said I'd kept that 0 there because it was equal to 0 from the entire beginning. But we need to verify a solution for A and C. So verifying our solution, oh, and actually, sorry, we didn't even get a solution. I kind of stopped at the factored form. So then we keep going, and we need to say 2x minus 5, when is that 0? We'll bring the minus 5 over, 2x equals 5, divide both sides by 2. So you get one solution, that's x of 5 over 2, so we'll need to verify that. And then this one right here, 3x plus 2 equals 0. When does that one equal 0? 3x equals minus 2. Divide by 3, divide by 3. X equals minus 2 thirds. Okay. Oh, I'll do it in red. So we need to verify our solution. So what that means is if you take this x value, this one right here, or this one right here, we should, when we substitute it back in to this quadratic or to this quadratic right up here, because they're the same quadratic, just written in different forms, we should get 0 if we did it correctly. So let's check. Let's do 6. We'll substitute this one in right here. So we get 6, 5 over 2 squared minus 11, 5 over 2 minus 10 equals, well, here we're going to get 25 over 2, so we get 150 over 4 if you do that first bracket there. And on this next one, you would get 55 minus 55 over 2 minus 10. So make everything a common denominator. You'll get 150 over 4 minus 110 over 4 minus 40 over 4, which you get 150 minus 150 over 4, which is 0 over 4, which is 0. So therefore, yes, that is a solution. Okay, you don't have to do all of this math. You could have just plugged it into a calculator. So we'll do that for this next one just to speed up some time, okay? So again, check this solution right here. 6 minus 2 over 3 squared minus 11 minus 2 over 3 minus 10. Okay, plug this into your calculator. And if you do that, you will get 0. So yes, that is a solution, okay? That is a value of x that would cause this to be y equals 0. All right, let's go again for part B. So here we go. We need to factor this, but first, before we factor, because this is a standard form, we need to have this set to 0. But clearly it's not set to 0, it's set to 2. So take away 2 from this side, take away 2 from this side, and then you will have it set to 0. Now you can factor. Same step as before. Check. Can you take this negative 2 out? Because that's clearly throwing us off. In this case, no, we can't. So let's do our decomposition. But actually, the first thing you know what? Before we even do decomp, we can take one part of this negative 2 out. We can take this negative out. So in doing that, you would get negative 2x squared minus 5x plus 2. All the signs just flip. And now do your decomp. So 2 times 2, you'll get 4. So we need two numbers that multiply to give us 4. And those same two numbers need to add up to give us minus 5. So what combination will do that for us? That will multiply to 4 and add up to negative 5. Well, you go through your 4's multiples. 2 and 2, 1 and 4. And again, keep in mind this is positive 1 and 4 right here. So that means I know if I was to make this negative 1 and negative 4, negative 1 and negative 4 will add up to negative 5. So then I can decompose that middle term. The negative is still out front. So instead, now this is minus 1x, or minus x, minus 4x plus 2, still equal to 0. Okay. Now do your grouping and take out your GCF from each one of those brackets. So from the 2x squared minus x, we can pull out a x, and that would leave us with 2x minus 1. And on the second bracket, minus 4x plus 2, we can pull out a, in this case, minus 2, because I want to get rid of this negative in front right here, because there's no negative here. So I will pull out a minus 2, and that would leave me with 2x minus 1. And again, the goal, get these brackets to be the same when you're doing it, which they are. So we have it in factored form, which our factored form is everything on the outside, x minus 2, and everything that was common, 2x minus 1. And we're solving, all right, I forgot in the last step, all right, we're not just stopping in factor form. Solving is then finding the values that make this equal to 0. Well, in reality, it's just saying take this bracket, this x minus 2, set it to 0, and solve for the x value. That would make it 0. So in this case, it would be 2. And you would do the same thing here. Take this bracket, 2x minus 1, set this one to 0. Bring the negative 1 over, so 2x equals 1. Divide both by 2, and you'll get x equals 1/2. And there you go. That is you solving, okay? So solve by factoring, well, you have two solutions. You have a solution at x equals 2 and a solution at x equals 1/2. Okay, let's keep going. 2x squared equals 8. All right, same step as before. We need to get rid of this 8 right here and make it 0. So take away 8 from both sides. And in doing that, you'll get 2x squared minus 8 equals 0. First step done. Now, your math survival guide should be like kicking in here and saying like, oh, this looks so different from the previous questions because here I only have 2 terms. And something very important is that these 2 terms are separated by a negative. So this possibly could be a difference of squares. But the thing is, 2, the square root of 2 is not a square. But if you recall, the first step is take out your GCF. So our GCF, our greatest common factor here, is if we take out a 2, this becomes x squared minus 4 equals 0. And now this is a difference of squares. Because 2, you can take the square root of x squared. This square root of x squared is x. And the square root of 4 is 2. So if you recall, your formula for difference of squares is you write your 2 squares, so x, and you separate them in the first bracket by a plus, 2. And then you in the other one, x, but now you put a negative, and then 2. There you go. See how much quicker that was in the previous problems? That is why we learn difference of squares and perfect square. Which makes much faster. Okay, now we have to keep going. We need to take this bracket right here, set it to 0, so x plus 2, set it to 0, bring the 2 over, x equals minus 2. That is one solution. And then do it again. Take this bracket, x minus 2, oops, I'll do it again. X minus 2 equals 0. Bring the negative 2 over, and it'll become a positive 2. Okay. But remember, we also need to check if these are actually solutions. So plug it back into the original problem. So take negative 2 and plug it into the original equation. So that would be 2 minus 2 squared. And I guess we can see if it equals 8. We'll just go back to the 0, minus. We brought that 8 over. And this should equal 0. Right, we're checking if it equals 0. Well, negative 2 squared is 2, 4, minus 8. So that's 8 minus 8. So then 0. So this is 0. So that means, yes, that is a solution. And do it again. 2. Do it for this one. 2 squared minus 8. So that becomes 2, 4 minus 8, 8 minus 8 again, and 0. So yes. Sorry, should I put equal signs? There you go. So yes, both of those are valid solutions. Both of those make the quadratic equal 0. And again, I always like to say a picture. You are finding the points right here and here when x is equal to 2, and when x is equal to minus 2, here the y is 0, and also here the y is 0. Those are your solutions. That's what you just found for this problem. And you'll have a quadratic that looks like this. Okay, last one for example 1. Let's factor this. So first step, make one side equal to 0. So let's get rid of this. So how do I get rid of that? Well, subtract it. Subtract 5x plus 3 from both sides. Subtract 5x plus 3 from both sides. So this and this will cancel, and you'll be left with 0 there. But then on the left-hand side, you'll have 2x plus 3 squared minus 5x plus 3. Okay, so I know this looks more complicated at first, but think of it kind of like grouping or that decomposition, right? You just kind of fast forward a few steps. Well, look here. This is your common bracket. You have an x plus 3 and an x plus 3 right here. So if you think about rewriting your common bracket or factoring out an x plus 3, or another way to visualize it is, let's say this x plus 3, let's call it z, right? So you have really 2, but then remember there is a squared on this one, so you have like 2z squareds minus 5z, so you can see that there's only one of these brackets here, one of those z's, but there's two of those there. So if I think about factoring what I have right here, well, I can pull a z from both of those terms there, and that would leave me with 2z minus 5 equals 0. Well, I don't want to know what z is. I want to know what that x plus 3 is. So plug that back in. So make z x plus 3. 2 times, because this is a multiply here, you're multiplying z by 2, and z is x plus 3 minus 5 equals 0. And then we have a bracket within a bracket, so distribute this 2 in to both of these terms. So you have x plus 3, 2x plus 6 minus that 5 still. And now collect these like terms right here. So you'll get x plus 3, 2x plus 1. And there you go, you have it in factored form. But solving the problem says find the x values and make it 0. So take your first factor, which is x plus 3, set it to 0. So bring the 3 over. X equals minus 3. That is one solution. And then do it again. Take this bracket, this 2x plus 1, set it to 0. Bring the plus 1 over, and you'll get 2x equals minus 1. Divide both sides by 2, and you'll get x equals minus 1/2. And there are your solutions. Okay, last example. Determine whether the given number is a root of the equation. Again, you'll see these words, and they have to. You'll see the word root, but you have to understand that this means the same thing as solution, x-intercept, 0. So they all mean the same thing, okay? So if you think about the definition of something being a root, so in this context of this problem right here, example 2a, this question is saying, does x, when x equals negative 2, is that a root? So big picture, what it's asking is saying that at an x value of minus 2, does this quadratic have a y-coordinate of 0? If it doesn't, then it is not a root, okay? So first thing, put this into proper standard form, right? So take this and bring it over here. So let's rewrite that as 4x squared plus 20x plus 25 equals 0. So now, if we take this x equals minus 2, and if we plug it in here, and for this x right here, And we find that after we do all our math, that on the left-hand side, this equals 0. So 0 essentially will equal 0. That means, yes, this is a 0. This is a root. This is an x-intercept. If this, I don't know, if this was like 5, well, clearly this does not equal 0. 5 does not equal 0. So no, that would not be a 0, okay? So that's what we're doing. We're just going to take x equals -2 and plug it in. So 4 minus 2 squared that plus 20 minus 2 plus 25 equals 0, or we're checking if it equals 0. So simplifying the first set, you have 4 times, and then -2 squared is 4, and then this positive 20 times -2, that becomes minus 40 plus 25 equals 0. This right here becomes 16 minus 40 plus 25. All right, well, 16 minus 40, that is what, 24, -24, minus 24 plus 25. So then this is 1 equals 0. Well, clearly 1 does not equal 0. It can't happen. So no. Therefore, x equals -2 is not a root. Okay, try it again on this side right here. Part B. Again, what you're doing is you're just substituting this in, this value of x equals -2, in for this x, and this x, and this x right here, and you're just seeing if it equals 0. But first off, let's set this one side to 0. So here we have a 5x and a plus 2. So let's take away a 5x and take away a 2 from both sides. So take away a 5x and take away 2. You'll be left with x plus 4 minus 5x minus 2 equals 0. So now check if x equals 2 is a factor or a root. So plug it in for this x, and this x again. So you get 2 plus 4, and then minus 5, 2, minus 2. Okay, I'm just going to write it all in one color now. All right. So simplify this first bracket right here. So that would be 2 times 6. Simplify this. -5 times 2 is minus 10, minus 2. This is 12 minus 10 minus 2. And all of this, 12 take away 10 take away 2, is 0. So 0 equals 0. Yes, that is a solution. X equal 2 is a root. It is a solution. So therefore, x equals 2 is a root. I'm going to call it a root because the question is saying the word root, right? And that's all for now. So pretty short lesson today.